Hello and welcome to the Science for Sleep channel. Tonight, we'll gently wander into a quiet and mysterious kingdom that surrounds us every day, yet so often goes unnoticed. A living world that thrives in shadows, beneath fallen leaves, inside decaying logs, and deep within the soil itself. This is the hidden world of mushrooms. Mushrooms are not quite plants, and not quite animals either, but something beautifully in between, belonging to a realm entirely their own. They breathe oxygen just as we do, releasing carbon dioxide back into the air. They grow silently, without sound or movement we can easily detect, unfolding their lives slowly in darkness and dampness. Long before the first forests stretched their branches toward the sun, fungi were already here, quietly shaping the evolution of life on Earth. Some mushrooms glow softly in the darkness, like tiny lanterns scattered across the forest floor, casting an eerie and gentle light through the night. Others spread vast and unseen beneath our feet, weaving together the roots of trees in a hidden network that scientists sometimes call a secret language of the forest. Still others dazzle the eye with colors so vivid and intense that they seem painted by hand, while a few conceal toxins so powerful that a single taste could end a human life. And yet, despite their dangers, mushrooms are also healers, builders, recyclers, and quiet dreamers. They help bread rise and turn grapes into wine. They break down death and decay, returning nutrients back to the living world. They can cleanse polluted soil, digest oil and plastic, and may even help us imagine how life could survive beyond our planet. If you enjoy these slow science explorations, feel free to like, subscribe, or leave a gentle thought in the comments below. Each small action helps another curious, sleepy soul find their way here. But for now, let us begin. Mushrooms are far more closely related to animals than to plants, a fact that surprises most people when they first hear it. Although mushrooms grow from the ground and live among trees and flowers, they are actually closer genetic relatives to humans than they are to grass or leaves. At a deep biological level, fungi share a common ancestor with animals, not plants. Like us, they breathe in oxygen and release carbon dioxide as part of their metabolism. Their cell walls are not built from cellulose, as plants are, but from chitin, the same tough material that forms the shells of insects, crabs, and other crustaceans. This unusual connection places fungi on a hidden branch of the family tree of life, one we rarely think about. When you walk through a forest, it may seem natural to group mushrooms with plants, but in truth, their closest companions are creatures that walk, swim, and fly. Realizing that a mushroom is, in a biological sense, more like you than like a blade of grass can quietly transform how you see the forest floor forever. Some mushrooms even glow with their own natural light. Imagine walking through a forest at night, where the darkness is gently broken by soft green or blue glimmers shining from the moss. These glowing mushrooms look like fairy lights woven into the earth itself. This phenomenon is called bioluminescence, the same type of natural light produced by fireflies and certain deep-sea creatures. More than 70 known species of mushrooms can glow this way, including the aptly named foxfire fungi. Scientists believe this light may help attract insects that spread the mushroom spores, or perhaps serve as a warning to animals that the mushrooms are not safe to eat. The glow is produced by a chemical reaction involving an enzyme called luciferase, turning chemical energy into living light. To witness one of these mushrooms in the wild is to see decay transformed into beauty, a quiet reminder that even as wood breaks down and life fades, something luminous can still emerge from the darkness. Beneath the surface of the ground lies an even greater mystery. Mushrooms themselves are only the fruiting bodies, the visible tips of a much larger organism known as mycelium. Mycelium is made up of countless thread-like filaments that weave through soil, stone, roots, and fallen leaves. In some places, these networks stretch for miles, forming immense living webs beneath forests and fields. Through these underground systems, fungi recycle nutrients, transport water, and even help plants share resources with one another. Trees can send sugars to neighboring trees, with fungi acting as silent messengers connecting the entire forest. It is as if the earth itself has veins made of living threads, pulsing slowly beneath our feet. When you walk across a meadow or forest path, you may unknowingly be stepping on a single massive organism, ancient, patient, and quietly alive everywhere. In fact, the largest living organism on Earth is a mushroom. Hidden beneath the blue mountains of Oregon lies something extraordinary. At first glance, the landscape appears ordinary, filled with pine trees, streams, and open meadows. But beneath the soil stretches a single fungal network known as the honey fungus. This colossal mycelium covers nearly 4 square miles and is believed to be thousands of years old. Every mushroom that appears above ground is only a small expression of this enormous being. This single organism outweighs the largest blue whale many times over and has lived silently longer than most human civilizations. When scientists finally uncovered its true size, they realized the forest was not made up of countless individual organisms, but was instead resting on one vast, ancient life form, spreading beneath the land like the slow heartbeat of the earth itself. Even more astonishing, mushrooms can communicate. Although fungi have no brains or nervous systems, they send electrical pulses through their mycelial networks. These pulses resemble the electrical signals fired by neurons in animal brains. Some researchers have discovered that the patterns of these pulses may carry information, changing in frequency in ways that resemble simple words or signals. Through this underground system, fungi may share warnings about danger, information about food, or changes in environmental conditions. It is as though an underground internet exists beneath the soil, transmitting messages in a language we are only beginning to understand. Imagine trees quietly sending nutrients to one another, with mushrooms acting as the couriers delivering the message. While this may not be thought as humans experience it, it is communication nonetheless, a reminder that intelligence can take many forms. Some species of fungi are so resilient that they can survive the harsh conditions of space. When scientists tested how life might endure beyond Earth, they exposed fungal spores to the vacuum, radiation, and freezing temperatures of outer space. To their amazement, many survived and were still capable of growing once returned to Earth. This resilience makes fungi fascinating subjects in astrobiology, the study of life beyond our planet. If fungal spores can survive the void of space, it raises the possibility that life itself could travel between planets, carried by dust or meteorites across the cosmos. This idea is known as panspermia, and fungi provide compelling evidence that such journeys may not be impossible. Even more remarkably, fungi have been found growing in nuclear reactors. After the Chernobyl disaster in 1986, scientists exploring the ruined reactor discovered mushrooms thriving in the radioactive environment. Certain species appear to grow toward radiation rather than away from it. These fungi contain melanin, the same pigment found in human skin, which may allow them to convert radiation into usable energy, much like plants use sunlight. It is as though these mushrooms are feeding on radiation itself, transforming what we consider deadly into fuel for growth. This discovery has enormous implications for the future. One day, fungi could help clean up nuclear waste or even protect astronauts from radiation during long journeys through space. And perhaps most hopeful of all, fungi can digest plastic and oil. Certain species are capable of breaking down materials that would otherwise persist in the environment for centuries. In 2011, scientists discovered a fungus in the Amazon rainforest that can consume polyurethane, one of the most stubborn plastics ever created. Other fungi have been shown to digest oil spills, turning toxic waste into harmless substances. Imagine landfills slowly shrinking, not through machines, but through quiet fungal colonies working patiently over time. In a world overwhelmed by pollution, fungi remind us that nature often holds the solutions to problems we have created, if only we are willing to learn from it. And yet, for all their beauty and usefulness, some mushrooms carry poison so potent that a single bite can end a life. A sobering reminder that wonder and danger often grow side by side in the natural world. Among the many wonders hidden within the world of mushrooms, there is also real and undeniable danger. Some species carry toxins so potent and so precise in their chemistry that even the smallest taste can be fatal. One of the most infamous examples is the death cap mushroom, Amanita phalloides, widely regarded as the deadliest mushroom on Earth. Its poisons work slowly and silently, attacking the liver and kidneys at a cellular level. What makes this mushroom especially terrifying is that its symptoms often do not appear for many hours, sometimes even days. By the time nausea, pain, and organ failure begin to show, the damage is already severe and often irreversible. Even more chilling is its appearance. The death cap looks harmless, even ordinary, with its pale greenish cap and gentle curves. It can easily be mistaken for an edible mushroom by the untrained eye. Throughout history, deadly mushrooms like this have taken the lives of kings, peasants, travelers, and entire families who never realized the danger they were facing. In the fungal kingdom, the line between nourishment and poison is razor thin and often invisible. And yet, within this danger lies a strange fascination. The idea that something so delicate and fragile-looking can hold enough chemical power to unravel a human life reminds us that nature, no matter how beautiful, always demands respect. But mushrooms are not only agents of danger. Many bring comfort, nourishment, and delight. Some species possess flavors so rich and familiar that they seem to mimic meat or seafood almost perfectly. The lobster mushroom, with its vibrant reddish-orange skin, carries a taste and aroma that recalls the sweetness of shellfish. Chicken of the woods, named for its layered, fan-like shape, tears into fibers that resemble chicken breast in both texture and flavor. Long before modern plant-based diets gained popularity, foragers across the world prized these mushrooms as natural alternatives to meat. To bite into one is to experience the remarkable versatility of fungi, to realize that something growing quietly from tree bark or forest soil can taste like a meal from the sea or the farm. It is as if mushrooms are shapeshifters of flavor, borrowing sensations from the animal world while remaining firmly rooted in their own mysterious kingdom. For thousands of years, mushrooms have also occupied a sacred place in human culture, not just in kitchens, but in rituals, ceremonies, and spiritual traditions. Ancient peoples were captivated by the way mushrooms seemed to appear overnight, as if summoned from the earth by unseen forces. In Siberia, shamans used the red and white Amanita muscaria, the iconic fairy tale mushroom, in ritual practices to enter trance-like states. In Mesoamerica, the Aztecs referred to sacred mushrooms as tiananacatl, meaning the flesh of the gods, and used them in ceremonies to communicate with the divine. Even prehistoric cave paintings in Spain, more than 6,000 years old, depict human figures holding mushrooms. These fungi were not simply food. They were gateways to visions, altered states of consciousness, and spiritual journeys. To our ancestors, mushrooms felt like messages from another realm, sprouting mysteriously from the ground to remind humans of the thin veil separating the ordinary from the extraordinary. Some mushrooms exhibit behavior that feels almost unsettlingly intelligent. One of the most eerie examples involves fungi known as cordyceps. These fungi do not simply grow quietly in soil. Instead, they infect insects and gradually take control of their behavior. A spore lands on an ant, and the fungus begins spreading inside its body. Over time, it releases chemicals that alter the ant's nervous system, forcing it to climb to a precise height on a stem or leaf. There, the ant locks its jaws and becomes motionless. Soon after, the fungus bursts from the ant's body, growing a stalk that releases spores onto the forest floor below. This chilling process has earned cordyceps the nickname zombie fungus. While disturbing, it also demonstrates the extraordinary evolutionary strategies fungi have developed to survive. Beneath the quiet forest floor, entire dramas unfold, where insects become unwilling actors in a silent fungal story. Fungi have even reshaped entire ecosystems on a global scale. In the late 20th century, scientists began noticing frogs, salamanders, and toads vanishing from habitats around the world. The cause was eventually identified as a fungus called Batrachochytrium dendrobatidis, often shortened to BD. This pathogen infects the skin of amphibians, disrupting their ability to absorb oxygen and regulate water. Because amphibians rely heavily on their skin for breathing and hydration, the infection is frequently fatal. Entire populations disappeared seemingly overnight, and BD is now considered one of the most devastating wildlife pathogens in recorded history. The idea that a microscopic fungus could alter ecosystems so dramatically reveals the immense, often hidden power fungi hold. Even today, conservationists race to protect vulnerable species, developing antifungal treatments and breeding programs. The story of BD reminds us that fungi are not only helpers and recyclers, but sometimes destroyers, capable of changing the course of life on Earth. The air you breathe is also filled with mushrooms. Every single breath carries microscopic spores, the fungal equivalent of seeds. Billions of these spores drift invisibly through cities, forests, deserts, and oceans. They fall with rain, rise on warm air currents, and travel for miles on the wind. Scientists estimate that a single cubic meter of outdoor air can contain thousands of spores at any given moment. You inhale them constantly without noticing, and your immune system is adapted to this ever-present rain of life. In fact, fungal spores are among the most common biological particles in Earth's atmosphere. Some are so light that they rise into clouds, meaning that every breath you take connects you to distant forests and ecosystems you may never see. You are always breathing in the quiet presence of mushrooms. Unlike seeds, which are often heavy and tied to the soil, spores are built for travel. Some are so small that they can remain airborne for astonishing lengths of time. Scientists have detected fungal spores more than 20 kilometers above Earth's surface, floating in the stratosphere. There, they can hitch rides on high-altitude winds, drifting across oceans and continents. Their protective outer coats shield them from ultraviolet radiation, dryness, and extreme temperatures. This incredible mobility makes fungi some of the most successful colonizers on the planet. Imagine a single spore released from a puffball mushroom in a quiet meadow, rising into the sky, and months later settling into soil on the other side of the world. Through spores, the atmosphere itself becomes a highway for life, invisible yet unceasing. Even more astonishing, some spores can survive exposure to outer space. In experiments where spores were subjected to vacuum, radiation, and freezing temperatures, many endured conditions that would instantly kill most organisms. Shielded by their tough protective layers, spores survived for days or even weeks outside spacecraft. This resilience has fueled the idea of panspermia, the possibility that life could spread between planets carried on dust, rocks, or meteorites. If fungal spores can survive such journeys, it suggests that life may be far more portable than we once believed, capable of traveling across the solar system or even the galaxy itself. When you see a mushroom releasing a cloud of spores, you may be witnessing a survival strategy so efficient that it could extend beyond Earth. Over time, mushrooms can even break down stone. We often think of rock as eternal, but fungi slowly prove otherwise. Certain lichens, partnerships between fungi and algae, secrete acids that dissolve minerals from rock surfaces. Over centuries, this process wears down cliffs and boulders, transforming solid stone into soil. In this way, fungi help create the very ground that plants depend on. Mountains are slowly softened, landscapes reshaped, and life prepared for what comes next. Through patience rather than force, fungi remind us that even the hardest materials yield to persistence. Without fungi and lichens, the surface of our planet might still be locked in bare, lifeless stone, unable to support forests, grasslands, or the green abundance we take for granted today. In a very real sense, fungi were Earth's first gardeners, quietly preparing the land for all the plant life that followed. Long before roots could anchor themselves in soil, fungi and lichens worked patiently to create that soil in the first place. By secreting mild acids and slowly breaking down rock, they transformed solid stone into fine mineral particles that could hold water and nutrients. Even now, you can see this process continuing on old tombstones, ancient ruins, and weathered monuments, where pale fungal patches slowly etch delicate patterns into the surface of the stone. With patience measured not in days or years, but in centuries, fungi quietly reshape the hard bones of the world. Their persistence is a reminder that even the strongest materials eventually yield to gentle, unrelenting effort. Some fungi leave their mark in far more whimsical ways. Step into a meadow after a rainfall, and you may notice a perfect ring of mushrooms rising from the grass, arranged so neatly it feels intentional, almost enchanted. These formations are known as fairy rings. They form as a single fungal organism grows outward in all directions beneath the soil. The mushrooms we see are merely the fruiting bodies, appearing along the advancing edge of the underground mycelium. Year after year, the ring expands, sometimes growing wider with each passing season. In folklore, fairy rings were believed to be the result of fairies dancing in circles under the moonlight, or gateways to other realms best avoided by humans. While science explains their formation through fungal growth, the magic has never entirely faded. To encounter a fairy ring is to witness living geometry etched into the earth, a perfect circle drawn by invisible threads beneath the grass, connecting the ordinary landscape to something timeless and quietly mysterious. Mushrooms also possess a remarkable ability to appear almost overnight. There is something deeply astonishing about their suddenness. One day, the forest floor looks bare, and the next morning it is dotted with fresh caps pushing through leaves and soil. Some mushrooms grow with incredible speed, swelling and rising in a matter of hours. This rapid growth is powered by the hidden mycelium below, which may have been storing energy for months or even years. When rain softens the ground and provides the moisture fungi need, the signal is given, and the mushroom surges upward, unfolding like a living time-lapse. This dramatic emergence has fueled countless myths, making mushrooms seem as though they are summoned by magic or spirits. In reality, it is biology at its most efficient. Long periods of invisible preparation followed by a brief and spectacular appearance. The next time you see mushrooms scattered across the ground after a storm, remember that they were already there, waiting patiently for the right moment to rise into the light. Long before synthetic pigments existed, humans also discovered that mushrooms could be used as natural dyes. Across many cultures, people learned that different fungal species could color cloth with surprising richness and beauty. Mushrooms and lichens can produce shades of gold, rust, green, purple, pink, and even deep blues. Species such as the dyers polypore yield warm yellows and oranges, while certain lichens create soft purples and rosy hues. Each species contains unique chemical compounds that, when boiled with fibers like wool or silk, release pigments that bind permanently to the fabric. These natural dyes often produce colors that shift subtly in different light, giving the cloth a living quality. To wear mushroom-dyed clothing was once to carry a piece of the forest with you, its colors woven into everyday life. Even today, artisans revive this ancient practice, honoring fungi not only as food or medicine, but as quiet artists painting the world with palettes hidden beneath the soil. While fungi are often imagined as gentle decomposers, some are surprisingly fierce hunters. Certain soil-dwelling fungi have evolved ingenious ways to trap and consume nematodes, tiny thread-like worms that move unseen through the dirt. These fungi build microscopic traps, sticky nets that ensnare passing worms, or elegant ring-shaped lassos that tighten instantly when touched. Once a nematode is caught, the fungus pierces its body and absorbs its nutrients, fueling further growth. The idea of a mushroom acting as a predator challenges our assumptions. These organisms do not chase or pounce, yet they hunt with patience and precision, weaving invisible traps beneath our feet. Entire battlefields of fungi and worms exist in the soil, unseen but constant, each quiet victory feeding the slow expansion of the fungal kingdom. Despite their delicate appearance, mushrooms can also be astonishingly strong. The fine threads of mycelium form dense, interlocking networks that distribute force efficiently. In fact, some mycelium-based materials have been shown to be stronger than steel when compared by weight. This combination of strength, lightness, and biodegradability has captured the attention of scientists and designers alike. Today, mycelium is being explored as a sustainable building material, used to create bricks, insulation, packaging, and even furniture. These materials are durable, fire-resistant, and fully compostable at the end of their life. It is remarkable to think that a fragile-looking mushroom on the forest floor could inspire structures capable of supporting homes. Mushrooms remind us that resilience does not always look imposing. Sometimes it is woven quietly, fiber by fiber, into humble forms of extraordinary strength. Fungi were also among the very first organisms to colonize land. Long before trees grew tall or flowers bloomed, fungi had already stepped onto the barren surface of ancient Earth. Fossil evidence suggests that fungi began colonizing land more than 1 billion years ago, helping to break down rock and create soil. Some scientists believe that enormous fungal organisms once dominated the landscape, including strange tower-like structures known as prototaxites, which may have stood over 20 feet tall. These towering fungi may have been the tallest living things of their era. Imagine a world without trees or grass, where giant fungal spires rose from a rocky landscape under an alien sky. Without fungi paving the way, the fertile, green planet we know today might never have existed. They were the quiet pioneers of life on land, shaping the world through patience rather than force. When we imagine mushrooms, we often think of caps large enough to pick and cook, but many fungi exist at the opposite extreme. Some mushrooms are so small they can rest on the head of a pin. These miniature fungi grow like specks of dust on decaying leaves or fallen twigs, visible only under magnification. Despite their tiny size, they perform the same vital tasks as their larger relatives, breaking down organic matter and releasing spores into the world. Some form delicate, crystalline structures with caps no larger than grains of sugar. Knowing that entire microworlds of fungi exist all around us, unseen by the naked eye, is deeply humbling. The forest is filled not only with towering trees and large mushrooms, but with countless hidden lives thriving in spaces too small for us to notice. At the other end of the scale, some mushrooms grow to astonishing sizes. Giant puffball mushrooms can swell to the size of beach balls, with some specimens weighing more than 20 pounds. When mature, a single puffball can release trillions of spores in a dramatic cloud that drifts across the landscape. In tropical forests, massive bracket fungi cling to tree trunks like shelves, some growing wide enough to serve as seats. These giant mushrooms have inspired awe and legend, appearing less like plants and more like creatures of myth. To stand beside one is to realize that mushrooms are not always small or fleeting. They can be monumental, enduring, and vast, their presence rivaling the creatures that walk among them. The fungal kingdom is truly a kingdom of extremes. Fungi exist at every scale imaginable, stretching from forms so small they escape the naked eye to networks so vast they span entire landscapes. Few groups of organisms display such dramatic contrast. Among the most famous examples of fungal mystery are truffles, the prized underground mushrooms whose scent alone can inspire obsession. Truffles release an aroma so intense and complex that it can drive animals into a frenzy. Their fragrance contains chemical compounds similar to pheromones, the natural signals many animals use to communicate attraction and readiness. For pigs in particular, this scent is irresistible, so much so that humans once relied on trained pigs to locate truffles buried deep beneath the soil. Today, dogs are more commonly used, as they can detect the scent with remarkable precision without devouring the treasure themselves. Humans, too, are captivated by truffles. They are among the most expensive foods in the world, valued not for their appearance but for their musky, earthy, intoxicating aroma that transforms entire dishes. This scent drifts through the soil, luring animals to dig them up, unknowingly spreading their spores in the process. Because truffles grow underground and cannot release spores into the air, they rely entirely on the strategy of attraction. Instead of wind, they use desire, a perfume so compelling that entire species are driven to seek them out, ensuring their survival through appetite and instinct. Deep within forests, mushrooms also make something extraordinary possible: communication between trees. Though forests may seem quiet, beneath the surface they are alive with exchange. Trees trade sugars, water, nutrients, and even warning signals with one another, and fungi make this cooperation possible. Mycorrhizal fungi form intimate partnerships with tree roots, extending their fine mycelial threads far into the soil. Through these underground networks, trees can share resources. A young or shaded tree may receive extra sugars from neighboring trees that receive more sunlight, passed gently along fungal pathways. If insects attack one tree or disease takes hold, chemical signals can travel through the fungal network, alerting nearby trees to activate their defenses. This hidden system of communication has become known as the Wood Wide Web. Without fungi, forests would be far less cooperative, and many young trees would fail to survive. The next time you walk through a forest, Imagine the roots beneath your feet not as isolated systems, but as part of a vast interconnected intelligence, with mushrooms acting as translators between towering giants. The Wood Wide Web does not simply connect individual trees, can link entire forests. A single mycelial network may bind dozens or even hundreds of trees into one interdependent community. Ancient mother trees can nourish seedlings through this underground web, sharing nutrients to help the next generation establish itself. Even dying trees may pass along their remaining resources, offering a final gift to the forest before they fall. Through this hidden system, a forest behaves less like a collection of individuals and more like a single living organism, responsive, adaptive, and deeply interconnected. What we see above ground, trunks, branches, and leaves is only half the story. Below, in the darkness of the soil, the fungal kingdom weaves a web as intricate as the neural networks in our own brains, sustaining the forest's quiet unity. Fungi also play a crucial role in storing carbon underground for centuries. Through their partnerships with plants, fungi help move carbon from the atmosphere into the soil, locking it away in vast underground networks of mycelium. Some of this carbon remains buried for hundreds of years, safely removed from the air. In this way, fungi act as natural climate regulators, slowing the buildup of carbon dioxide that contributes to global warming. Forests owe much of their power as carbon sinks to the fungal networks that keep nutrients cycling and carbon stored. Even when fungi break down organic matter, they carefully regulate how quickly carbon is released back into the atmosphere. In an age where climate change dominates human concern, the humble mushroom may prove to be one of Earth's most effective guardians, working silently beneath the soil to maintain balance in the global system. Some mushrooms thrive in places that humans find unpleasant. Certain species grow exclusively on animal dung. While this may sound unappealing, it is a brilliant survival strategy. Dung is rich in nutrients already partially processed by an animal's digestive system, and fungi are perfectly equipped to recycle what remains. Species such as inky caps sprout directly from manure, breaking it down and returning its nutrients to the soil. Some of these mushrooms have evolved an astonishing trick. They launch their spores with explosive force, sending them far beyond the dung pile. This allows the spores to land on fresh grass, where grazing animals may eat them, restarting the cycle. What seems like waste to us is opportunity to fungi. In their world, nothing is discarded, not even the most unlikely materials of life. Other mushrooms wait patiently for destruction before they appear. These are known as fire-loving fungi. They remain dormant in the soil until wildfire sweeps through a forest, clearing vegetation and leaving behind ash. Then, almost as if summoned, mushrooms such as morels emerge in abundance. Fire changes the chemistry of the soil, creating conditions these fungi require. Burned forests can become treasure troves of morels, prized by foragers for their honeycombed caps and rich, earthy flavor. Beyond human fascination, these fungi play an essential ecological role. They rapidly recycle nutrients, helping forests recover after devastation. Where flames have consumed, mushrooms rise, transforming destruction into renewal. In this way, fungi act as the forest's first responders, quietly preparing the ground for rebirth. Fungi are also natural chemists. Long before humans discovered medicine, fungi were producing compounds to defend themselves against bacteria and microbes. One of the most famous examples is penicillin, discovered in a mold closely related to mushrooms. But mushrooms themselves also contain antimicrobial compounds, some of which are being studied for future medical use. In nature, these chemicals help fungi survive in crowded environments filled with competitors. For humans, they are reminders that powerful solutions often lie hidden in plain sight. The next time you see a mushroom growing from a fallen log, imagine it as a tiny laboratory, quietly crafting chemicals not just for its own survival, but perhaps for the healing of life far beyond its forest home. And without fungi at all, many of the staples of human culture would vanish. Without fungi, bread would never rise, beer would never ferment, and much of civilization's shared comfort and tradition would simply not exist. The simple, everyday miracle of bread rising gently in the oven, or beer forming a soft, shimmering foam in a glass, is made possible by fungi. What feels ordinary in our daily lives is actually the result of an ancient biological partnership. At the heart of this process is yeast, a single-celled organism and a microscopic relative of mushrooms. Though invisible to the human eye, yeast performs a powerful transformation, consuming sugars and converting them into alcohol and carbon dioxide. This chemical exchange is what fills bread with tiny pockets of air, giving it its soft, tender texture, and what creates the bubbles that sparkle in beer, wine, and champagne. Without fungi, human cuisine would be unrecognizable. There would be no warm loaves breaking open with steam, no wine poured at ceremonies, no frothy Alesh shared in quiet conversation. Archaeologists have uncovered evidence of fermentation dating back thousands of years, revealing that humans and fungi have been partners since the dawn of civilization. In this sense, fungi have shaped culture just as deeply as they have shaped forests, influencing rituals, economies, celebrations, and everyday nourishment. Every time you tear open a loaf of bread or slowly sip a fermented drink, you are tasting the invisible labor of fungi, a quiet collaboration that has endured across centuries. The yeast used in baking is itself a fungus, though it is easy to forget that the granules sprinkled into dough or poured into a brewer's vat are alive. These microscopic organisms feed on sugars, multiply rapidly, and release gases that lift dough and bring liquid to life with fizz. Though tiny, yeast are among humanity's oldest companions. They were likely discovered by chance, when wild yeast drifting through the air settled on crushed fruit or damp grains, triggering spontaneous fermentation. Over generations, humans learned not only to recognize this process, but to guide it, refine it, and depend on it. Yeast became the unseen workers of kitchens and breweries, shaping entire food traditions without ever being seen. Modern yeast strains may be carefully bred and controlled, but they remain members of the fungal kingdom, distant cousins of the mushrooms that push through forest soil after rain. Within every loaf of bread and every bottle of wine, billions of fungal cells work together in silence, turning sweetness into substance and reminding us that life's most powerful systems often operate out of sight. Some mushrooms reveal their mysteries not through taste or usefulness, but through startling appearance. In certain forests, you might encounter a mushroom that appears wounded, its pale surface dotted with drops of bright red liquid that resemble fresh blood. One of the most striking examples is Hydnellum pecii, often called the bleeding tooth fungus. Despite its unsettling look, the red fluid is not blood, but a thick, sap-like exudate rich in pigments and chemical compounds. Scientists continue to debate its purpose. It may help regulate moisture, deter insects, or protect the fungus from harmful microbes. To stumble upon such a mushroom feels deeply uncanny, as though nature itself is echoing familiar symbols in unsettling ways. These bleeding fungi remind us that the forest is not designed for human comfort or understanding. We are only temporary observers, wandering through a world where even mushrooms can drip crimson jewels into the moss for reasons entirely their own. Other mushrooms rely not on sight, but on scent, and some of those scents are deliberately revolting. Certain species survive by producing odors that closely mimic rotting flesh. Known as stinkhorns, these fungi emit powerful smells that attract flies and beetles, which mistake them for decaying matter. The insects land on the mushroom and unknowingly carry its spores away, spreading the fungus to new locations. What humans experience as disgust is, for the mushroom, an elegant survival strategy. In folklore, stinkhorns have often been linked to spirits or omens, their sudden appearance and foul aroma inspiring superstition. In reality, they are simply masters of chemical manipulation, evolving to turn repulsion into opportunity. In the stillness of a forest, a sudden whiff of decay may not signal death at all, but the thriving life of a mushroom skillfully playing tricks on the senses of every creature that passes. Beneath the forest floor, fungi construct entire hidden worlds. When mycelium spreads underground, it does not form random threads, but intricate, layered networks that resemble vast subterranean cities. Filaments branch, merge, and reconnect, forming highways through which nutrients and information flow. Some regions act like marketplaces, exchanging resources with plant roots, while others serve as storage vaults, holding reserves for times of scarcity. Scientists using advanced imaging have discovered that these networks are remarkably efficient, optimizing pathways in ways similar to human-designed infrastructure. In this sense, fungi are natural engineers, constructing living architectures that rival our own cities in complexity. While humans raise skyscrapers and pave roads above ground, the fungal kingdom quietly weaves sprawling metropolises below, where billions of organisms cooperate in silence. The soil beneath your feet is not empty, but alive with a society of threads, a city without walls, softly pulsing with life. Some mushrooms reveal their secrets the moment they are touched. Certain species change color when bruised, handled, or cut. The blue staining bolete, for example, transforms from an unassuming brown into a vivid cobalt blue as soon as its flesh meets the air. This dramatic shift is caused by chemical reactions between compounds inside the mushroom and oxygen. For foragers, the color change can serve as an identification clue, though it does not always indicate whether a mushroom is safe to eat. The transformation feels almost magical, as if the mushroom is briefly revealing a hidden identity. In folklore, such mushrooms were thought to be enchanted, imbued with secret powers. Even today, touching one can evoke that same ancient wonder, a fleeting moment when chemistry feels indistinguishable from sorcery. Not all mushroom scents repel. Some are unexpectedly sweet and comforting. Certain species release fragrances that resemble maple syrup, coconut, almonds, or marzipan. The candy cap mushroom, for instance, carries an aroma nearly identical to maple syrup, growing even stronger as it dries. Chefs prize it for desserts, using it to flavor cookies, cakes, and ice creams, transforming a forest find into culinary magic. These scents come from chemical compounds called lactones, which trick the human brain into associating the mushroom with sweetness. To encounter such a mushroom in the wild is like discovering a hidden kitchen beneath the trees. It is a reminder that fungi are master chemists, capable of crafting scents that repel, attract, or simply astonish. From the stench of rot to the perfume of sugar, mushrooms compose an invisible symphony of smells, written in molecules we are only beginning to understand. Mushrooms also carry a quiet nutritional gift. Few foods naturally contain vitamin D, yet mushrooms can produce it themselves. Like humans, they rely on sunlight. When ultraviolet rays touch a mushroom skin, compounds inside are converted into vitamin D, a nutrient essential for strong bones, immune health, and emotional balance. A handful of sun-dried mushrooms can contain as much vitamin D as a supplement. Some cultures intentionally place freshly harvested mushrooms in sunlight before cooking them, increasing their nutritional value. Though mushrooms often grow in dark forests and shaded fields, when touched by light they store its energy, becoming a living bridge between sun, soil, and life itself. Some mushrooms exist at a strange intersection where danger and beauty meet, where toxins do not merely defend but also illuminate. In certain species of fungi, poisonous compounds are linked to an extraordinary ability to glow in the dark. These bioluminescent mushrooms emit a soft, ethereal green or blue light, produced by chemical reactions involving luciferin and the enzyme luciferase. The same fundamental process appears in fireflies and deep-sea creatures, yet in mushrooms it takes on a quieter, more haunting form. Scientists believe this glow may serve multiple purposes at once. It may deter animals that instinctively avoid glowing organisms, or it may attract insects that help spread spores through the forest. Some researchers even suggest it could act as a signal, a chemical message written in light. At night, entire patches of forest floor can seem to shimmer faintly, as though stars have fallen into the moss. To encounter such mushrooms is both enchanting and unsettling. Dangerous organisms glowing softly, as if lit from within. In ancient folklore, glowing fungi were often interpreted as signs of spirits, omens, or supernatural presences. Though science explains the chemistry behind the glow, the sense of wonder remains. Life, even in its most toxic forms, finding a way to transform defense into radiance. Among the most feared fungi on Earth is the death cap mushroom, Amanita phalloides. It appears deceptively harmless. A pale green cap, a smooth white stalk, an unremarkable shape that blends easily among edible species. Yet hidden within this fragile body is amatoxin, one of the most lethal substances known in nature. Just half of a single mushroom can be enough to kill a healthy adult. What makes the death cap especially cruel is its delay. Symptoms often do not appear for many hours after ingestion, creating a false sense of safety while irreversible damage begins inside the body. The liver and kidneys slowly fail, and by the time the danger is recognized, options are limited. There is no true antidote. Hospitals can offer supportive care, sometimes even liver transplants, but survival is never guaranteed. Throughout history, this single mushroom has been responsible for countless accidental deaths, from peasants to nobles. Its existence is a sobering reminder that nature does not advertise its dangers. Beauty and terror coexist quietly in the forest, and mushrooms, so often healers and recyclers, can also carry lethal secrets written in chemistry rather than warning signs. Yet fungi are not only agents of danger. In one remarkable moment in history, a mushroom helped save the world from disease. During the 19th century, cholera ravaged cities across Europe and Asia, spreading fear as quickly as it spread death. Medical understanding was limited, and cures were desperately sought. During this time, researchers observed that a fungus known as Penicillium glaucum, related to the mold that would later give us penicillin, could inhibit the growth of the cholera bacterium. Though the mechanisms were not fully understood, this discovery offered early evidence of fungi's medicinal power. Decades later, the development of antibiotics confirmed what this mold had quietly demonstrated. Fungi possess compounds capable of altering the course of human history. Entire populations trembling under the threat of disease found relief not in grand inventions, but in humble fungal growths. That moment foreshadowed the antibiotic revolution, proving that mushrooms and their relatives can stand as silent guardians between humanity and its deadliest enemies. Even more astonishing is the growing evidence that fungi can remember past conditions. Though they lack brains or nervous systems, fungi have demonstrated a form of biological memory. In laboratory experiments, mycelial networks exposed to changes in temperature, moisture, or nutrient availability responded differently when those same conditions returned. The second response was faster, more efficient, as though the fungus had learned from experience. This memory is not conscious thought, but a physical record encoded in the structure and chemistry of the fungal threads themselves. Such adaptive recall may explain why fungi are among the most resilient organisms on Earth. They do not simply react. They adjust, remember, and refine their responses. To walk through a forest is to move through a living archive, where underground networks quietly recall storms, droughts, fires, and seasons long past. In this sense, the soil itself remembers, its memory carried in delicate threads beneath your feet. Some mushrooms demonstrate resilience in an even more dramatic way. In the depths of winter, when the ground freezes solid and most life retreats or dies back, certain fungi endure. Some species can freeze completely, their cells filled with ice crystals, and yet revive when temperatures rise. Others continue to fruit beneath snow, pushing fragile caps through frost as if untouched by the cold. Their survival depends on antifreeze-like compounds that protect their cells from rupture. For organisms that appear so delicate, this toughness is extraordinary. It allows mushrooms to thrive in tundra, alpine regions, and other extreme environments. To encounter a mushroom emerging from snow is to witness quiet defiance. Life persisting where it seems impossible, continuing its slow work even when the world appears locked in ice. For thousands of years, humans have recognized this quiet power and turned to mushrooms as medicine. Across cultures and continents, fungi have been revered as healers. In traditional Chinese medicine, the reishi mushroom was called the mushroom of immortality, believed to strengthen the body and extend life. In Japan, shiitake mushrooms were once reserved for nobility, valued as tonics for health and vitality. Indigenous peoples in Siberia, North America, and Africa developed their own fungal remedies, brewing teas, applying poultices, and using mushrooms to treat wounds, fevers, and exhaustion. Modern science now confirms what ancient healers sensed through experience. Many mushrooms contain compounds that boost immune function, reduce inflammation, and even show promise in fighting cancer. When someone drinks mushroom tea or uses a medicinal extract today, they are participating in a tradition stretching back thousands of years, a testament to the enduring bond between humans and fungi. Among the most intriguing medicinal mushrooms is lion's mane, named for its cascading icicle-like spines. Beyond its striking appearance, lion's mane holds remarkable potential. Studies in animals have shown that compounds within this mushroom, known as hericenones and erinacines, can stimulate the production of nerve growth factor. This molecule plays a crucial role in repairing and maintaining neurons. As a result, lion's mane has become a subject of intense scientific interest as a potential therapy for neurodegenerative conditions such as Alzheimer's and Parkinson's disease. Though research is ongoing, the possibility that a mushroom could help regenerate nerve cells reshapes how we think about healing. Once again, fungi reveal themselves not as simple organisms, but as complex partners in life's resilience, quietly holding solutions that science is only beginning to uncover. For centuries, this remarkable mushroom has held a place of reverence in traditional Asian medicine, where it was valued as a powerful tonic for the brain and nervous system. Ancient healers believed it could sharpen the mind, strengthen memory, and restore balance to thought itself. Today, modern science is beginning to uncover why those beliefs endured for so long. Imagine a mushroom, soft and white, cascading downward like a frozen waterfall, delicate in appearance yet carrying within it the potential to influence the most intricate networks of the human mind. Within its fibrous structure are compounds that interact with neurons, encouraging growth, repair, and communication. It stands as a quiet reminder that some of the most advanced solutions to human medical challenges may still be hidden in overlooked corners of the forest, growing silently on fallen wood, waiting to be understood. Some mushrooms reveal their magic not through healing, but through spectacle. Puffball mushrooms possess a uniquely playful and dramatic method of reproduction. As they mature, their round bodies slowly fill with millions, sometimes billions, of microscopic spores. These spores remain sealed inside until the perfect moment arrives. A falling raindrop, the step of an animal, a gust of wind, or even the gentle poke of a curious human finger can trigger their release. Suddenly, the mushroom erupts in a cloud that looks like a puff of smoke rising from the forest floor. What appears to be smoke is actually a shimmering storm of life, each tiny spore a capsule of possibility drifting into the air. For children and foragers, puffballs are often a source of wonder, like nature's own miniature fireworks. Yet beneath the delight lies an incredibly effective survival strategy. In a single moment, vast numbers of spores can be carried far from the parent mushroom, increasing the chances that the species will endure. To witness a puffball release its cloud is to see persistence itself, disguised as a fleeting trick of smoke and light. Fungi also perform one of the most essential roles in every forest on Earth: decomposition. When autumn arrives and fallen leaves blanket the ground, fungi immediately begin their patient and tireless work. Without them, forests would slowly suffocate beneath their own debris. Fungi release powerful enzymes capable of breaking down cellulose and lignin, the tough compounds that give wood and leaves their strength. What appears to be decay is, in truth, a finely tuned recycling system. Nutrients locked inside dead plant matter are freed and returned to the soil, where they nourish new life in spring. Every blooming flower, every towering tree, every blade of grass owes part of its existence to this hidden process. Fungi are the unseen caretakers of the ecosystem, ensuring that nothing is wasted and that death is transformed back into life. To walk through an autumn forest is to tread upon an invisible economy powered by mushrooms, one that has functioned for millions of years. Without fungi, life on Earth would drown in its own remains. Each year, countless leaves fall, branches snap, trees collapse, and animals die. Without fungal decomposers, this organic matter would accumulate endlessly, burying landscapes under layers of decay. Fungi are the planet's great recyclers, dismantling even the toughest biological materials and returning them to the cycles of soil, air, and water. If fungi were to disappear, forests would grind to a halt, trapped beneath their own weight, and renewal itself would cease. Every step taken on a forest floor is possible only because billions of fungal threads have quietly cleared the way, dissolving the past into the foundation of future growth. In silence and patience, fungi keep the earth livable, breathable, and endlessly renewed. Some mushrooms remain hidden during the day, blending perfectly into bark, soil, and shadow, only to reveal themselves when night falls. In darkness, bioluminescent fungi awaken, glowing softly in shades of green, blue, or yellow. They emerge like ghostly lanterns scattered across the forest floor. The light is produced by a delicate chemical reaction inside their cells, similar to the process that allows fireflies to shine. Some species glow only at night, as though conserving their energy for darkness alone. To encounter them in a night forest is to feel transported into another world, one where mushrooms light their own paths. For centuries, these glowing fungi inspired legends of spirits and enchanted forests. Even today, they stir the imagination, reminding us that the forest holds wonders visible only when the sun disappears. Fungi are also capable of remarkable cooperation. Lichens, those colorful patches clinging to rocks, trees, and cliffs, are not single organisms at all. They are partnerships between fungi and algae or cyanobacteria. The fungus provides shelter, structure, and moisture, while its partner produces food through photosynthesis. Together, they form entirely new life forms capable of surviving in the harshest environments on Earth, from Arctic tundra to barren deserts, even the vacuum of space. Lichens are among the planet's oldest colonizers, slowly breaking down rock and preparing the way for soil and plants. In this relationship, fungi act not just as scavengers, but as farmers, cultivating their partners in one of nature's earliest examples of cooperation. Not all mushrooms are safe to eat raw, even if they are not poisonous. Some contain compounds that only cooking can neutralize. Morels, prized by chefs worldwide, are one such example. Raw, they can cause illness, but when cooked, they transform into rich, nutty delicacies. Others, like shiitake mushrooms, release deeper flavors and nutrients only when heat unlocks their chemistry. Cooking completes their transformation, turning potential harm into nourishment. This knowledge, passed down through generations of foragers, highlights the importance of respect and preparation. Mushrooms teach us that food is not always simple. Sometimes it requires patience and understanding to reveal what lies beneath. Some mushrooms go even further, defending themselves not with toxins, but with bitterness so intense they are impossible to eat. The bitter bolete closely resembles edible relatives, yet its flavor is so acrid that a single bite can spoil an entire meal. These compounds act as deterrents, warning animals away without resorting to poison. For humans, bitterness serves as an alarm, a sensory signal telling us to stop. In this way, mushrooms communicate through taste, reminding us that the forest is filled with signals meant to guide survival, not comfort. Within the fungal kingdom, even bitterness and toxicity are not flaws, but carefully evolved tools of survival. Mushrooms that are unpleasant or dangerous to eat still play essential roles in the ecosystems around them. Though avoided by animals, they quietly recycle organic matter, break down fallen wood, and enrich the soil beneath them. They serve as reminders that the forest is not designed solely for human use. Taste itself becomes a language, a subtle negotiation between species, signaling who may partake and who must move on. In this silent dialogue, fungi help shape balance, ensuring that every organism finds its place. What repels one creature may protect another, and what cannot be eaten still nourishes the land in unseen ways. Among the most fascinating and controversial members of the fungal world are those capable of producing natural hallucinogens. Certain mushrooms synthesize compounds such as psilocybin, chemicals powerful enough to alter human perception in profound ways. These substances can dissolve the boundaries of time, distort space, intensify emotion, and create sensations of deep interconnectedness with nature and the self. For thousands of years, such mushrooms were used deliberately in spiritual and ceremonial rituals, believed to open pathways to hidden realms of understanding. Shamans and healers saw them as bridges between worlds, tools for insight rather than indulgence. Today, science has returned to these fungi with cautious curiosity, studying their potential to ease depression, anxiety, trauma, and addiction. That a delicate mushroom can influence consciousness so deeply is nothing short of astonishing. It suggests that fungi do not merely recycle forests, but can also reshape the inner landscapes of the human mind. Whether revered, feared, or medically embraced, these mushrooms occupy a rare space where biology and mystery intertwine. The bond between humans and these fungi may stretch back further than written history. In caves scattered across regions of Spain and Algeria, ancient paintings depict human figures holding shapes that closely resemble mushrooms. Some researchers believe these images hint at early ritual use, possibly tied to altered states of awareness. The artwork shows dancing forms, radiating patterns, and abstract bursts of color that echo experiences commonly reported during hallucinogenic journeys. Though certainty remains elusive, the idea that humans were exploring fungal consciousness tens of thousands of years ago is deeply compelling. It suggests that mushrooms may have influenced not only survival, but imagination, symbolism, and the earliest expressions of art. To picture ancient people gathered around flickering firelight, painting mushrooms onto stone walls as symbols of transformation, is to feel a thread of continuity stretching across millennia. In the modern world, fungi are offering solutions not to the mysteries of the mind, but to the mounting crisis of waste. As plastic pollution overwhelms ecosystems, mycelium is emerging as a promising alternative. By growing fungal networks into molds, scientists can create lightweight yet durable packaging materials. Once dried, these forms resemble polystyrene foam, yet they are entirely biodegradable. Already, companies are using mushroom-based packaging to protect electronics, furniture, and fragile goods. After use, the material can be composted, returning harmlessly to the soil. Agricultural waste feeds the mycelium, making the process both renewable and efficient. Where plastic lingers for centuries, fungi complete a natural cycle of creation and return. It is remarkable to imagine that the same organism fruiting quietly in a forest could one day cradle your packages, then dissolve back into earth without a trace. Some mycelium-based materials offer yet another unexpected advantage: natural resistance to fire. Researchers have discovered that certain fungal composites do not ignite easily. Instead of bursting into flame or releasing toxic smoke, they slowly char and smolder. This makes them promising candidates for insulation, furniture, and building materials. The secret lies in the structure of fungal cell walls, rich in chitin and complex sugars that resist burning. Nature, through fungi, has engineered materials humans are only beginning to understand. The idea that walls grown from mycelium could one day protect homes from fire reshapes how we think about construction. Hidden threads that once stitched forest floors together may soon help safeguard human shelters. Fungi are also transforming fashion and design. Traditional leather, prized for its durability, comes at significant environmental and ethical cost. Mycelium leather offers an alternative. Grown rather than harvested, this fungal material can be cultivated in sheets, treated, and finished to resemble animal leather in both look and feel. Designers already use it to create shoes, handbags, and furniture. Unlike animal hides, which require years and vast resources, mycelium leather can be produced in weeks using minimal water and no cruelty. Its texture can be tuned, from soft and suede-like to smooth and polished. That the same organism forming mushrooms can also become wearable material feels almost surreal. Fungi prove themselves not only recyclers and healers, but inventors, offering materials that unite sustainability with beauty. In cold forests, fungi reveal yet another secret of survival. Certain mushrooms produce compounds that function like natural antifreeze. These molecules lower the freezing point of water inside their cells, preventing damaging ice crystals from forming. As a result, some fungi can remain active even in frozen soil, continuing their work while other life sleeps. In some cases, these antifreeze compounds influence the surrounding environment, easing frost in the immediate area. Scientists now study these substances as models for protecting crops from frost and developing safer de-icing solutions. A tiny mushroom, no larger than a hand, quietly defying winter becomes a lesson in resilience. Fungi are also master miners. Without tools or strength, they extract minerals directly from rock. By releasing organic acids, fungal networks slowly dissolve stone, freeing elements like calcium, potassium, and magnesium. Over immense spans of time, this process turns barren rock into fertile soil. More than 1 billion years ago, fungi may have helped prepare Earth's surface for plant life. Even today, lichens steadily etch cliffs and gravestones, reshaping landscapes grain by grain. Their persistence is relentless and transformative. Inspired by this ability, scientists now imagine biomining techniques modeled after fungi, extracting valuable minerals with far less environmental damage than conventional methods. In every role they play, fungi demonstrate a quiet power. They reshape minds, recycle worlds, protect homes, and mine mountains, all without noise or recognition. A hidden kingdom beneath our feet, offering tools not only for survival, but for the future itself. Tio stand before a rugged rocky outcrop and slowly realize that it is being quietly consumed, molecule by molecule, by invisible fungal threads. Is to witness patience transformed into power. What appears solid, eternal, and unmoving is, in truth, constantly changing under the influence of life working at a pace too slow for human senses to notice. Fungi do not attack stone with force. They dissolve it gently, releasing minerals 1 grain at a time, reshaping landscapes not through violence, but through persistence. In this silent process, patience becomes a form of strength, and time itself becomes a tool. In places where human life struggles to survive, mushrooms sometimes flourish in astonishing ways. At Chernobyl and other radiation-contaminated sites, scientists have discovered fungi growing directly within rubble soaked in radioactive energy. These fungi contain melanin, the same pigment found in human skin, but here it appears to serve a far stranger role. Instead of merely protecting the organism, melanin may help convert radiation into usable energy through a process known as radiosynthesis. Imagine a form of photosynthesis that does not rely on sunlight, but instead feeds on radiation we consider deadly. What humans fear as poison becomes fuel for fungal life. These discoveries hint at extraordinary possibilities. Fungi that could help clean radioactive waste, shield astronauts from cosmic radiation, or survive environments once thought completely uninhabitable. In the ruins of disaster zones, mushrooms quietly demonstrate nature's astonishing adaptability, transforming danger into nourishment and proving that life can endure even where survival seems impossible. Long before such extreme environments existed, fungi may have played a crucial role in shaping life on land itself. When the first green plants emerged from the oceans hundreds of millions of years ago, they encountered a harsh and unforgiving world of bare rock, scarce nutrients, and no soil. Yet they were not alone. Fossil evidence suggests fungi were already present, ready to form partnerships. Through these early alliances, fungal networks helped plants extract vital minerals from rock, while plants repaid the fungi with sugars produced through photosynthesis. Over immense spans of time, these exchanges created the planet's first thin soils, laying the groundwork for forests, grasslands, and complex ecosystems. Without fungi, plants may never have established themselves on land at all, and Earth might have remained silent, barren, and gray. Every tree, every meadow, every blade of grass carries the legacy of this ancient partnership. When you walk across a field today, you are stepping on ground prepared by fungi hundreds of millions of years ago, a silent debt written into the living skin of the planet. Though mushrooms are often associated with forests, the fungal kingdom extends far beyond soil and trees. In the oceans, marine fungi form hidden partnerships with coral reefs, weaving unseen threads through the vibrant architecture of underwater ecosystems. These fungi may help regulate nutrients, protect corals from disease, or stabilize reefs against environmental stress. Though still poorly understood, marine fungi could prove essential to coral survival as oceans warm and acidify. To imagine fungi drifting among coral polyps is to realize that their reach extends into saltwater as well as soil. If corals are the architects of reefs, fungi may be their quiet caretakers. Even beneath the waves, life is built upon cooperation, not isolation. Fungi are also masters of reproduction, possessing a level of flexibility few organisms can match. They reproduce asexually by releasing enormous numbers of spores, creating genetic copies that spread rapidly through soil and air. This strategy allows them to colonize new environments with incredible speed. At the same time, fungi also reproduce sexually, exchanging genetic material to create variation and resilience. Some species can even switch between reproductive methods depending on environmental conditions, choosing speed when expansion is needed and diversity when survival is threatened. Each mushroom you encounter may represent a long chain of clones or a unique genetic blend, a visible reminder that fungi contain many strategies for life within a single organism. This diversity reaches astonishing extremes in fungal mating systems. Some species possess tens of thousands of mating types, the functional equivalent of genders. The split-gill mushroom alone may have over 20,000 compatibility types encoded in its DNA. These are not genders in the human sense, but genetic systems that allow nearly any two individuals to reproduce successfully. This prevents inbreeding and generates immense genetic diversity. Where humans often imagine gender as simple or binary, fungi explode the concept into thousands of possibilities. Their mating systems reveal evolution's creativity and remind us that life is never constrained by human categories. For fungi, diversity is not rare. It is fundamental. When reproduction reaches its most dramatic display, few sites rival the puffball mushroom. As it matures, it fills with a fine powder of spores, waiting for release. A raindrop, a falling twig, or a curious touch can trigger an eruption, sending a smoky cloud into the air. What looks like dust is actually a storm of microscopic lives. A single puffball can release trillions of spores, more than the total number of humans who have ever existed. Most will fail to grow, but a few will land in just the right place, ensuring the continuation of the species. Watching a puffball burst is like watching the forest exhale, a moment where invisibility briefly becomes visible and possibility scatters into the wind. These spores do not remain confined to forests. Air currents carry them higher and higher, above trees, rooftops, and skyscrapers. Scientists have detected fungal spores thousands of feet above cities, drifting among dust and pollen. Some are swept into clouds, returning to Earth with rain over distant landscapes. Every breath taken in an urban environment contains traces of forests, soils, and fungal worlds far away. Even surrounded by concrete, humans remain connected to the hidden networks of fungi. The air itself becomes a bridge between wild and urban spaces, carrying spores as constant, invisible messengers across the planet. The next time you walk down a crowded street, surrounded by the constant hum of traffic, distant conversations, and glowing storefronts, remember that the fungal kingdom is still with you. It drifts invisibly above your head, riding air currents between buildings, settling briefly on glass and stone before lifting again. Though unseen, fungal spores float endlessly through the atmosphere, linking your breath to forests, wetlands, gardens, and ecosystems you may never personally visit. Every inhale becomes a quiet exchange with distant landscapes. Even in cities of concrete and steel, fungi remind us that no human environment is ever truly disconnected from the natural world. These spores are tiny beyond imagination, yet they may influence something as vast as global weather itself. Once lifted into the atmosphere, spores can act as nuclei around which water droplets begin to form. Cloud particles gather around them, growing heavier until rain finally falls. In this way, fungi may quietly participate in the timing and distribution of rainfall across the planet. Forests may not only recycle nutrients underground through roots and fungal networks, but also reach upward into the sky, sending spores aloft to help summon moisture from the air. Though scientists are still studying this phenomenon, it suggests that mushrooms influence far more than soil and decay. They may extend their reach into atmospheric systems, blurring the boundary between earth and sky. Imagine rain forming around spores released from a distant forest floor, drifting for days before falling onto rivers, farms, and cities far away. Fungi dissolve borders, reminding us that life flows continuously upward, outward, and across the planet. In landscapes scarred by pollution and industrial damage, fungi often emerge as silent healers. Certain mushroom species possess an extraordinary ability to absorb heavy metals such as lead, mercury, arsenic, and cadmium from contaminated soil. Their mycelial networks spread like living veins through poisoned ground, drawing toxins inward and binding them within their tissues. This process, known as mycoremediation, offers a powerful alternative to excavation, chemical treatment, or burning. While the mushrooms themselves become unsafe to consume, they serve a greater purpose by cleansing the environment around them. Imagine a ruined industrial site where mushrooms rise quietly from toxic soil, acting as natural filters that concentrate danger and slowly return land to life. In their patient labor, fungi demonstrate that healing does not always arrive loudly or quickly. Sometimes restoration begins invisibly, thread by thread. Mushrooms may also help repair some of humanity's most devastating environmental disasters. When oil spills seep into land or water, their effects can linger for decades, choking ecosystems and suffocating life. Yet certain fungi can break down hydrocarbons, the core molecules that make up oil. Their mycelium releases enzymes capable of dismantling thick black sludge, transforming it into simpler, harmless compounds. In experimental settings, areas treated with fungi have shifted from oily wastelands into fertile ground where plants, insects, and birds return within weeks. This process suggests mushrooms could play a role in restoring landscapes damaged by human activity. Picture an oil-soaked shoreline slowly turning green again, not through machines alone, but through fungal networks spreading beneath the surface. Nature, it seems, often hides its remedies within the organisms we overlook. Beyond their environmental power, mushrooms also surprise us through the senses. While most are associated with earthy, savory flavors, some rare species produce aromas and tastes reminiscent of chocolate or cocoa. These flavors come from unique aromatic compounds that interact with our senses in ways similar to chocolate itself. Though uncommon, these mushrooms reveal the remarkable diversity hidden within the fungal kingdom. Imagine walking through a damp forest expecting the scent of soil and leaves, only to catch a warm, sweet fragrance like a bakery tucked among the trees. For chefs and foragers, these fungi blur the line between forest and comfort, offering flavors that feel familiar yet entirely unexpected. Other mushrooms surprise not through taste, but through light. In tropical forests and humid woodlands, certain fungi glow with a soft green radiance after nightfall. This bioluminescence is caused by a chemical reaction involving luciferin and luciferase, similar to the glow of fireflies. Scientists believe the light may help attract insects, which unknowingly carry spores to new locations. To encounter these glowing mushrooms in darkness is to feel as though the forest itself has lit lanterns along the ground. For centuries, travelers told stories of foxfire and fairy fire, mysterious lights shimmering from rotting wood. Today, we understand that these stories were inspired by mushrooms revealing a hidden brilliance. Even in darkness, life finds ways to glow. Long before modern forests existed, fungi themselves once dominated Earth's landscapes. Hundreds of millions of years ago, enormous fungi known as prototaxites rose up to 30 feet tall, making them the tallest organisms of their time. These towering structures stood like solitary pillars across barren terrain, shaping early ecosystems long before trees appeared. They broke down rock, helped form soil, and prepared the land for the plant life that would eventually follow. Though modern mushrooms are small and fleeting, their ancestors once ruled the planet. They were giants of a forgotten age, guardians of the world before forests. Some fungi display a resilience that borders on the unbelievable. While water is often considered essential for life, certain fungi and lichens can survive complete desiccation. They dry out entirely, appearing lifeless for years or even decades. Yet when moisture returns, they awaken and resume growth as if time had paused. Special sugars and protective proteins stabilize their cells during drought, allowing them to endure extreme heat, cold, and radiation. Scientists study these organisms for clues about how life might survive on Mars or other arid worlds. Imagine a brittle fungal thread lying dormant for years, springing back to life with the first touch of rain. In their stillness, these fungi teach us that survival does not always require struggle. Sometimes it requires patience beyond measure. Mushrooms have not only conquered forests, fields, and cities, they have also been carried beyond Earth itself. The remarkable resilience of fungi has drawn the attention of space agencies and researchers, leading to experiments that send mushrooms and fungal spores into orbit aboard spacecraft. Exposed to microgravity, intense cosmic radiation, and the vacuum-like conditions of space, many fungi have done more than merely survive. Some continue to grow, spreading delicate filaments even in environments that would cripple most life forms. Others altered their internal chemistry, adjusting pigment levels, metabolism, and protective compounds in response to conditions far more extreme than anything found on Earth. These observations suggest that fungi are not passive organisms, but responsive systems capable of rapid adaptation. Scientists now speculate that fungi could play vital roles in future space missions, recycling waste, helping produce food, stabilizing closed ecosystems, or even forming biological shields against radiation. There is even discussion of whether fungal spores, tough enough to endure cosmic travel, could drift between planets, seeding life across space. Whether or not this occurs, the sight of mushrooms growing in orbit forces us to reconsider the limits of life. A fungus that can persist beyond Earth hints that this quiet kingdom may hold a place not only in forests, but among the stars. Back on Earth, fungi also work tirelessly beneath our crops, strengthening the foundations of global food systems. Below fields of wheat, corn, rice, and vegetables, microscopic fungal networks intertwine with plant roots in ancient partnerships. These mycorrhizal fungi extend the effective reach of roots, helping plants absorb nutrients and water while also enhancing their resistance to disease. They stimulate plant immune responses, making crops more resilient to pests and pathogens. Some fungi actively outcompete harmful microbes, forming living barriers that protect roots from infection. Farmers and scientists are increasingly turning to these fungal allies, using inoculants to reduce dependence on chemical pesticides and fertilizers. This approach reframes agriculture not as a war against nature, but as a collaboration with it. Fields strengthened by fungal networks mirror forests, where resilience comes from cooperation rather than force. In this underground alliance lies a blueprint for sustainable farming shaped over millions of years. Mushrooms are also indispensable to modern medicine, serving as sources of life-saving drugs that extend far beyond antibiotics. Fungi produce an astonishing diversity of chemical compounds, many of which interact powerfully with the human body. Some lower cholesterol, others suppress immune responses to prevent organ rejection, while still others show promise in slowing or stopping cancer growth. Drugs that transformed cardiology and transplant medicine were first discovered in fungi quietly growing in soil. Researchers continue to explore forests, grasslands, and even urban environments, searching for new fungal compounds that could become tomorrow's medical breakthroughs. Traditional medicine recognized the healing properties of mushrooms long before laboratories existed, but modern science is now uncovering just how deep this pharmacological potential runs. Each mushroom cap and strand of mycelium may carry molecules capable of altering the course of human health. To walk through a forest is, in a sense, to move through a living pharmacy, where cures lie hidden beneath bark, leaves, and moss, waiting patiently to be found. One of the most important medical discoveries in history began with a fungus. In 1928, Alexander Fleming noticed that a mold, Penicillium notatum, had killed bacteria growing nearby in a forgotten petri dish. That observation led to penicillin, the first widely used antibiotic. During World War II and the decades that followed, penicillin saved millions of lives by turning once fatal infections into treatable conditions. Though not a mushroom in the traditional sense, Penicillium belongs to the fungal kingdom, underscoring how deeply fungi are woven into human survival. That quiet mold reshaped medicine forever, reminding us that some of the greatest revolutions emerge not from grand inventions, but from careful attention to nature's smallest workers. Fungi also transform everyday life through fermentation. Every loaf of bread that rises and every glass of wine that ferments owes its existence to yeast, single-celled relatives of mushrooms. These organisms consume sugars and release carbon dioxide and alcohol as byproducts. In bread dough, trapped gas slowly inflates the loaf, giving it structure and softness. In wine and beer, fermentation shapes flavor, aroma, and character. A sourdough starter becomes a living ecosystem, containing wild yeasts and beneficial bacteria that respond to temperature, flour, and time. Bakers learn to interpret its behavior by scent and sound, while winemakers speak of terroir not only in terms of soil and climate, but in microbial life. Fermentation is chemistry, but it is also rhythm. Fungi guiding sugars toward nourishment, celebration, and tradition, one invisible breath at a time. Mushrooms have also inspired art across centuries and cultures. Their forms appear in folk embroidery, illuminated manuscripts, botanical illustrations, ceramics, architecture, and modern design. Artists are drawn to their domes, gills, and rib geometries, shapes that echo cathedrals, umbrellas, and natural spirals. Art Nouveau borrowed their curves, while contemporary designers reinterpret their structures in lamps, buildings, and textiles. Photographers crouch low to capture glowing fungi at night, transforming forests into constellations. Children's stories embrace mushrooms as symbols of magic, surprise, and hidden worlds. Beyond aesthetics, mushrooms function as metaphors for emergence and transformation, appearing suddenly when conditions align. Art returns to them again and again because they invite closer attention, urging us to look beneath the surface. Perhaps most mysterious of all, fungi may even communicate in ways we are only beginning to detect. Though mushrooms have no mouths or ears, researchers using sensitive instruments have recorded faint ultrasonic clicks produced as mycelium shifts fluids and pressure within its tissues. Scientists also measure electrical pulses traveling through fungal networks, rhythmic spikes that change with moisture, light, or disturbance. Some artists translate these signals into sound, transforming fungal activity into ambient music that ebbs and flows like breath. Whether these signals represent coordination, stress responses, or resource sharing remains under study. Yet the idea is captivating. A forest humming softly beneath our feet, alive with signals we rarely perceive. If we listen closely enough, the soil itself may be speaking. Just as a heartbeat and the rise and fall of breath establish the tempo of a living body, every organism carries its own rhythm. Whether these rhythms are deliberate signals or simple byproducts of growth, they reveal that life moves according to internal timing. Exposed to microgravity, intense cosmic radiation, and the vacuum-like conditions of space, many fungi have done more than merely survive. Some continue to grow, spreading delicate filaments even in environments that would cripple most life forms. Others altered their internal chemistry, adjusting pigment levels, metabolism, and protective compounds in response to conditions far more extreme than anything found on Earth. These observations suggest that fungi are not passive organisms, but responsive systems capable of rapid adaptation. Scientists now speculate that fungi could play vital roles in future space missions, recycling waste, helping produce food, stabilizing closed ecosystems, or even forming biological shields against radiation. There is even discussion of whether fungal spores, tough enough to endure cosmic travel, could drift between planets, seeding life across space. Whether or not this occurs, the sight of mushrooms growing in orbit forces us to reconsider the limits of life. A fungus that can persist beyond Earth hints that this quiet kingdom may hold a place not only in forests, but among the stars. Back on Earth, fungi also work tirelessly beneath our crops, strengthening the foundations of global food systems. Below fields of wheat, corn, rice, and vegetables, microscopic fungal networks intertwine with plant roots in ancient partnerships. These mycorrhizal fungi extend the effective reach of roots, helping plants absorb nutrients and water while also enhancing their resistance to disease. They stimulate plant immune responses, making crops more resilient to pests and pathogens. Some fungi actively outcompete harmful microbes, forming living barriers that protect roots from infection. Farmers and scientists are increasingly turning to these fungal allies, using inoculants to reduce dependence on chemical pesticides and fertilizers. This approach reframes agriculture not as a war against nature, but as a collaboration with it. Fields strengthened by fungal networks mirror forests, where resilience comes from cooperation rather than force. In this underground alliance lies a blueprint for sustainable farming shaped over millions of years. Mushrooms are also indispensable to modern medicine, serving as sources of life-saving drugs that extend far beyond antibiotics. Fungi produce an astonishing diversity of chemical compounds, many of which interact powerfully with the human body. Some lower cholesterol, others suppress immune responses to prevent organ rejection, while still others show promise in slowing or stopping cancer growth. Drugs that transformed cardiology and transplant medicine were first discovered in fungi quietly growing in soil. Researchers continue to explore forests, grasslands, and even urban environments, searching for new fungal compounds that could become tomorrow's medical breakthroughs. Traditional medicine recognized the healing properties of mushrooms long before laboratories existed, but modern science is now uncovering just how deep this pharmacological potential runs. Each mushroom cap and strand of mycelium may carry molecules capable of altering the course of human health. To walk through a forest is, in a sense, to move through a living pharmacy, where cures lie hidden beneath bark, leaves, and moss, waiting patiently to be found. One of the most important medical discoveries in history began with a fungus. In 1928, Alexander Fleming noticed that a mold, Penicillium notatum, had killed bacteria growing nearby in a forgotten petri dish. That observation led to penicillin, the first widely used antibiotic. During World War II and the decades that followed, penicillin saved millions of lives by turning once fatal infections into treatable conditions. Though not a mushroom in the traditional sense, Penicillium belongs to the fungal kingdom, underscoring how deeply fungi are woven into human survival. That quiet mold reshaped medicine forever, reminding us that some of the greatest revolutions emerge not from grand inventions, but from careful attention to nature's smallest workers. Fungi also transform everyday life through fermentation. Every loaf of bread that rises and every glass of wine that ferments owes its existence to yeast, single-celled relatives of mushrooms. These organisms consume sugars and release carbon dioxide and alcohol as byproducts. In bread dough, trapped gas slowly inflates the loaf, giving it structure and softness. In wine and beer, fermentation shapes flavor, aroma, and character. A sourdough starter becomes a living ecosystem, containing wild yeasts and beneficial bacteria that respond to temperature, flour, and time. Bakers learn to interpret its behavior by scent and sound, while winemakers speak of terroir not only in terms of soil and climate, but in microbial life. Fermentation is chemistry, but it is also rhythm. Fungi guiding sugars toward nourishment, celebration, and tradition, one invisible breath at a time. Mushrooms have also inspired art across centuries and cultures. Their forms appear in folk embroidery, illuminated manuscripts, botanical illustrations, ceramics, architecture, and modern design. Artists are drawn to their domes, gills, and rib geometries, shapes that echo cathedrals, umbrellas, and natural spirals. Art Nouveau borrowed their curves, while contemporary designers reinterpret their structures in lamps, buildings, and textiles. Photographers crouch low to capture glowing fungi at night, transforming forests into constellations. Children's stories embrace mushrooms as symbols of magic, surprise, and hidden worlds. Beyond aesthetics, mushrooms function as metaphors for emergence and transformation, appearing suddenly when conditions align. Art returns to them again and again because they invite closer attention, urging us to look beneath the surface. Perhaps most mysterious of all, fungi may even communicate in ways we are only beginning to detect. Though mushrooms have no mouths or ears, researchers using sensitive instruments have recorded faint ultrasonic clicks produced as mycelium shifts fluids and pressure within its tissues. Scientists also measure electrical pulses traveling through fungal networks, rhythmic spikes that change with moisture, light, or disturbance. Some artists translate these signals into sound, transforming fungal activity into ambient music that ebbs and flows like breath. Whether these signals represent coordination, stress responses, or resource sharing remains under study. Yet the idea is captivating. A forest humming softly beneath our feet, alive with signals we rarely perceive. If we listen closely enough, the soil itself may be speaking. Just as a heartbeat and the rise and fall of breath establish the tempo of a living body, every organism carries its own rhythm. Whether these rhythms are deliberate signals or simple byproducts of growth, they reveal that life moves according to internal timing. In fungi, researchers have detected faint clicking sounds and electrical pulses as mycelium shifts fluids, pressure, and nutrients through its networks. These subtle signals may not be language in the human sense, yet they remind us that living structures are never static. A mushroom's rhythm is slow, deliberate, and exact, measured not in seconds but in hours, days, and seasons. It is the patience of something that does not rush because it has endured longer than most kingdoms on Earth. That patience allows fungi to inhabit places where life seems impossible. In some of the driest deserts on the planet, where sunlight scours stone and water arrives only as rumor, fungi retreat into rock itself. These organisms, known as endolithic fungi, live inside microscopic pores of stone. Threads as thin as hair yet as resilient as braided rope. Temperatures swing violently from scorching heat to freezing cold, and still they persist. In Antarctica's dry valleys, among the harshest environments on Earth, these fungi inhabit translucent quartz, surviving on the faintest filtered light penetrating just a few millimeters deep. Their chemistry is ancient and efficient. Organic acids slowly dissolve minerals, pigments shield against radiation, and metabolism drops to a near standstill, ready to awaken when a thin film of meltwater briefly appears. To call this survival is insufficient. It is ingenuity written at the molecular scale. Split open a stone and you may not find emptiness, but a hidden city of filaments, quietly reshaping geology grain by grain. Life, it turns out, often begins just beneath the skin of the world. Some fungi do not merely adapt to environments. They manipulate other lives entirely. In tropical forests, a single fungal spore can land on an ant and begin one of nature's most unsettling transformations. Inside the ant's body, the fungus grows carefully, threading through muscle tissue while leaving the brain largely intact. Through chemical signals, it alters behavior, guiding the ant away from its colony and compelling it to climb to a precise height on vegetation. There, the ant bites down in a final, irreversible grip and becomes still. From its body, a fruiting stalk eventually erupts, releasing spores onto the forest floor below. This phenomenon, often called the zombie ant fungus, is not cruelty, but strategy. Evolution distilled into choreography. A climb, a bite, a pause. Nature does not judge. It optimizes. Closely related fungi, such as cordyceps, expand this eerie artistry across the insect world. Caterpillars become pillars. Beetles harden into platforms for slender spears of fungal growth. Spiders frozen mid-motion sprout delicate branching structures like antlers. Each species of cordyceps is finely tuned to a specific host, a relationship refined over millions of years. Enzymes soften tissue, fungal threads replace internal structures, and eventually the fungus emerges to fruit. The sight unsettles because it dissolves boundaries. Animal becomes architecture, parasite becomes gardener. Yet this process also returns nutrients to the ecosystem and helps regulate insect populations. What appears grotesque is also balance, written in biological sculpture. Not all fungi inspire dread. Some delight through their miniature elegance. Kneel in damp leaf litter and you may discover what looks like a tiny bird's nest cradling glossy eggs. These are bird's nest fungi, and the eggs are spore packets called peridioles. When raindrops strike the cup at just the right angle, the peridioles are flung outward with remarkable precision. Sticky cords allow them to latch onto twigs, leaves, or passing animals, hitching rides to new territory. This is physics perfected at the scale of a raindrop. Geometry, impact, and trajectory aligned into a silent dispersal system. Once noticed, These tiny nests seem to multiply everywhere, entire nurseries operating unnoticed at ground level. Whimsy executed with engineering precision. Other mushrooms appear more ominous. In shaded forests, blunt black clubs rise from the soil like half-remembered hands. Known as dead man's fingers, these fungi recycle buried wood, marking where trees once stood. Elsewhere, coral fungi branch upward in pale chandeliers, delicate yet purposeful. These shapes feel gestural, almost expressive, though they exist solely to release spores efficiently into moving air. Their unsettling names are our own projections, reflections of the stories we impose on unfamiliar forms. Look long enough and the drama fades. These structures weather, crumble, and return to soil, while the mycelium beneath endures, steady and unseen, patient as stone, persistent as time itself. It is a quiet lesson the forest offers again and again. Much of what matters most remains hidden. A life can unfold beneath the surface, unseen and uncelebrated, and still be the truest part of the story. Fungi embody this truth perfectly. Their most important work happens underground, out of sight, while the visible mushroom is only a brief signature on the surface of a much larger existence. Some mushrooms announce themselves not through height or color, but through texture. Their caps gleam as though polished, coated in a slick layer of slime that beads with moisture like fresh varnish. You could almost see your reflection in their wet sheen. This slippery surface is not an accident or aesthetic flourish. In many bolete and swilla species, the viscous cap acts as a moisture-retaining shield, preventing delicate tissues from drying out in wind or sun. It is a living raincoat, a hydration layer designed to keep the mushroom functional long enough to release its spores. In stinkhorn fungi, slime takes on an entirely different role. Here, the glossy coating becomes a foul-smelling bait. The gelatinous gleba reeks of decay, mimicking rotting flesh so convincingly that flies are irresistibly drawn to it. They land, feed, and depart with spores clinging to their legs like powdered footprints. What appears repulsive to us is an elegant dispersal system, a taxi service paid for with deception. To human senses, slime signals danger or decay. To fungi, it is a toolkit, protection, perfume, billboard, and delivery system all at once. Touch one, and your fingers come away tacky, carrying the unmistakable message that in the forest, function comes before beauty, and even gloss has work to do. At other times, mushrooms abandon subtlety entirely and explode into color. On certain mornings, the forest seems to forget its muted palette. Indigo milk caps bruise deep blue, amethyst deceivers scatter violet tones among fallen leaves, and wax caps rise from old meadows in sherbet pinks, lemon yellows, and glowing reds. These colors arise for many reasons. Some pigments shield against sunlight, others act as antioxidants, while some may signal to insects or simply result from complex chemistry piggybacking on survival traits. To stumble upon a bright blue mushroom is to feel a moment of disbelief, like discovering a tropical fish stranded in a woodland puddle. Photographers crouch low to capture these improbable jewels. Cobalt caps beneath moss, purple stems framed by rust-colored oak leaves. These colors remind us that forests are not monochrome. They are stained glass windows laid flat, illuminated by sky above and painted from below by the slow chemistry of soil. Even in places where life seems impossible, fungi endure. In the dry silence of deserts, where plants shrink into thorns and animals retreat underground, fungi persist in forms both subtle and astonishing. Some live hidden inside rocks, protected from wind and sun by mineral walls. Others form lichens, partnerships between fungi and algae or cyanobacteria, creating living skins that cling to stone. The algae capture sunlight and produce food, while fungi provide shelter, structure, and moisture storage. In the Atacama Desert, one of the driest regions on Earth, scientists have found fungi surviving on salt crystals and mineral veins, living on mist so thin it barely qualifies as water. Their tolerance for heat, cold, drought, and radiation is extraordinary. They redefine what survival means. Through fungi, life whispers even in landscapes we label lifeless, proving again that the boundaries of possibility are far wider than we imagine. Long before humans, long before mammals, fungi were already feeding giants. When dinosaurs thundered through prehistoric forests, mushrooms were present, recycling nutrients and sustaining ecosystems. Fossil evidence suggests that fungi flourished during the Cretaceous period, growing in soils thick with decaying vegetation. Some mushrooms may have been grazed directly by herbivorous dinosaurs, plucked from the ground like primitive snacks. Others partnered with plant roots, sustaining forests that fed enormous bodies. Imagine a massive sauropod lowering its head across a swampy clearing dotted with mushrooms as large as dinner plates. In a world before flowering plants, fungi were already maintaining the cycles of life, acting as both food and infrastructure. Even the largest creatures to ever walk the earth depended on the quiet work of fungal networks beneath their feet. The fossil record confirms just how ancient this kingdom truly is. While bones and shells fossilize easily, fungi leave behind delicate traces. Yet scientists have uncovered fossilized filaments and spores dating back more than 400 million years to the Devonian period. Some of these fossils preserve early mycorrhizal partnerships, proving that fungi were already collaborating with plants to build soil from bare rock. Even more astonishing, a fossil discovered in the Canadian Arctic reveals fungal networks nearly 1 billion years old. These remains suggest fungi were among the earliest complex life forms on Earth, predating plants and possibly even animals. To imagine such an organism thriving in a world utterly alien to ours is to confront time on a scale almost beyond comprehension. And yet, their descendants still sprout in our gardens and kitchens, linking our present moment to a nearly unimaginable past. Sometimes, the hidden order of fungi briefly surfaces. Mushrooms can arrange themselves in precise arcs, spirals, and perfect circles. These patterns emerge naturally as mycelium grows outward underground, exhausting nutrients at the center and fruiting at the expanding edge. From above, the result can look intentional, as if geometry itself has risen from the soil. Spirals echo the mathematics seen in shells and sunflowers, shapes dictated by efficiency rather than design. To encounter such a formation in a meadow is to feel that an unseen blueprint has momentarily revealed itself. Mushrooms sketch equations in living ink, reminding us that beauty often arises not from intention, but from process. Not all spores rely on wind. Some are designed to hitch rides. Spiky, sticky, or wrapped in barbed coatings, they cling to insects as they pass. Beetles, ants, and flies become unwitting couriers, transporting spores far beyond what air currents alone could achieve. Some fungi sweeten the deal with sugary secretions or glowing signals, ensuring insects come close enough for contact. Others grow precisely where pollinators brush past. Movement becomes currency. For insects, the exchange is invisible. For fungi, it is survival multiplied. The forest hums with these silent transactions, spores boarding wings like passengers embarking on journeys into the unknown, trusting in the restless wanderings of the smallest travelers in the air. And through all of this, fungi quietly anchor nutrients in soil, locking them into cycles that sustain forests, fields, and futures yet to unfold. Fungi are the great recyclers of the living world, tirelessly breaking down fallen leaves, dead wood, and the countless remains of once living things. Yet their role goes far beyond simple decay. As fungi decompose organic matter, they transform it into forms that can be reused, and just as importantly, they help keep those nutrients exactly where they are needed. Beneath the forest floor, sprawling networks of mycelium weave through the soil, binding individual particles together like living thread. This binding prevents precious nutrients from being washed away by rain, anchoring them in place instead of letting them drain into rivers and oceans. In forests, this creates something like a living sponge beneath the surface. Phosphorus, nitrogen, carbon, and trace minerals are absorbed, stored, and slowly released back into the soil where plant roots can reach them. Without fungi performing this quiet work, soils would rapidly lose fertility. Plants would struggle, forests would thin, and entire ecosystems would weaken. Even in agricultural fields, fungal networks stabilize nutrients, keeping them available for crops rather than allowing them to leach away. Imagine the underground web not as chaos, but as a careful steward, tucking nourishment into hidden pockets, safeguarding it until the moment of need arrives. In this way, fungi are not only recyclers, but guardians, invisible custodians of soil health, maintaining the balance that allows forests, farms, and grasslands to endure. Beyond nutrients, fungi also build infrastructure for life itself. Mycelium is not merely a private network serving the fungus alone. Research has revealed that bacteria travel along fungal threads like commuters using highways. These thin filaments provide firm, continuous pathways through soil that would otherwise be fragmented and impassable. Along these routes, bacteria spread more efficiently, colonizing new areas and forming partnerships with fungi in return. Some share nutrients, others assist in breaking down compounds, creating a web of mutual support. Underground, a hidden ecosystem thrives, complete with corridors, intersections, and exchanges. Without fungi, many microbes would remain isolated in tiny soil pockets. With fungi, the earth becomes a bustling metropolis, alive with traffic and trade. Soil is not empty dirt. It is a crowded city, and fungi are the engineers who laid down the roads. Some mushrooms engage our senses in surprising ways. Lift the cap of a freshly picked field mushroom or champignon, and you may notice a scent that feels instantly familiar. Warm, yeasty bread fresh from the oven. This aroma comes from volatile compounds also produced by yeasts during fermentation, a shared chemistry that links fungi to baking and brewing. For foragers, this smell can aid identification, a kind of sensory handshake between species. But the fragrance is more than pleasant coincidence. Aromatic compounds can attract insects and animals, increasing the chances that spores will be brushed against and carried away. For humans, the experience feels uncanny. To inhale the scent of bread in the middle of a forest is to feel comfort in an unexpected place, as though kitchen and wilderness briefly overlap. It is a reminder that the boundary between the cultivated and the wild is thinner than we imagine. Other mushrooms release aromas that recall spice cabinets rather than bakeries. Some toadstools exude the sweet, licorice-like scent of anise, while certain milk caps smell distinctly of cinnamon. These fragrances arise from chemical compounds similar to those found in the spices themselves. For us, stumbling upon these scents in damp woodland feels almost magical. For fungi, the aromas serve practical purposes, attracting insects or discouraging predators. Mycologists often rely on smell as a crucial identification tool, kneeling close to inhale the secret signatures of different species. Each scent is a note in the forest symphony, invisible but unforgettable. Mushrooms are chemists as much as recyclers, distilling complex environments into fragrances that linger in memory long after the encounter ends. Mushrooms also interact intimately with water. When rain falls, many species swell rapidly, sometimes doubling their weight overnight. Their tissues, built from chitin and specialized cells, function like microscopic reservoirs, absorbing moisture with remarkable efficiency. This ability allows mushrooms to appear suddenly after storms, transforming bare ground into a landscape of caps and stems almost overnight. Yet the water they store is not solely for themselves. As mushrooms slowly release moisture back into surrounding soil, they create damp microhabitats that support insects, mosses, seedlings, and countless microorganisms. In this way, mushrooms act as living sponges, regulating humidity and sharing resources. Rain is captured, remembered, and gently returned to the ecosystem. Each fruiting body becomes a vessel, carrying the memory of rainfall into the rhythms of the forest. Some fungi even produce their own light. Bioluminescent mushrooms glow with a soft green radiance in the darkness, shining continuously for days or even weeks. This glow comes from a chemical interaction between luciferin and luciferase, similar to the process used by fireflies, though steadier and more patient. Scientists believe the light may attract nocturnal insects, increasing spore dispersal. Imagine walking through a rainforest at night and seeing clusters of mushrooms glowing beneath ferns like embers scattered across the ground. The light is gentle, unwavering, and strangely reassuring, proof that life remains active long after sunset. For centuries, people called this phenomenon foxfire or fairy fire, weaving stories around glowing logs and enchanted woods. Today, we understand the chemistry, but the wonder persists. Fungi quietly illuminating the night from within the earth itself. Across human history, mushrooms have also played profound cultural roles. For thousands of years, societies around the world have incorporated fungi into spiritual and ceremonial practices. In Mesoamerica, the Aztecs referred to certain mushrooms as tiananacatl, the flesh of the gods used to bridge the human and divine. In Siberia, shamans consumed Amanita muscaria, the iconic red-capped mushroom, seeking visions and altered states of consciousness. Indigenous cultures across Africa, Asia, and the Americas wove mushrooms into healing rituals, fertility rites, and initiations, treating them as teachers and intermediaries. These traditions recognized mushrooms as liminal beings, existing between life and decay, darkness and light, the visible and the unseen. Even today, they remind us that fungi occupy a threshold space, connecting worlds we are only beginning to understand. Even in the modern world, mushrooms remain woven into spiritual exploration and emerging medicine. Researchers today study certain species for their potential to ease anxiety, soften depression, and reduce the deep existential fear that shadows human consciousness. Long before laboratories and clinical trials, cultures across continents recognized mushrooms as more than nourishment or danger. They were teachers, symbols, thresholds between ordinary perception and something vast and unnamed. Across centuries, fungi have been regarded as guides, opening doors not only to altered states of mind, but to reflection, humility, and connection. They occupy a strange middle ground between science and mystery, between the measurable and the ineffable, reminding us that some knowledge is felt as much as it is understood. Beyond symbolism, mushrooms reveal astonishing physical abilities. While most species rely on wind or rain to carry their spores, others employ dramatic mechanical strategies. Inky caps and puffballs build internal pressure until spores are released in smoky clouds, erupting like silent explosions. Other fungi push this principle even further. Species such as Pilobolus construct microscopic pressure chambers that store energy until it is unleashed in a single instant. Spores are fired outward with remarkable force, traveling meters away from the parent organism. To the naked eye, this happens invisibly. Under a microscope, however, it resembles fireworks at the smallest imaginable scale. This explosive launch ensures spores escape the crowded shadow of their origin, landing in open territory where life can begin again. What appears to us as still forest air is, at the fungal scale, alive with motion, bursts, arcs, and trajectories carrying futures forward. In fact, the fastest recorded movement in all of biology belongs not to an animal, but to a fungus. Pilobolus, a tiny dung-loving species, launches its spores at speeds exceeding 20 meters per second, with acceleration greater than a bullet leaving a gun. The spore capsules build immense pressure relative to their size, then rupture, hurling their cargo across astonishing distances, sometimes more than 2 meters, hundreds of times the height of the fungus itself. This ensures spores land on fresh vegetation, ready to be eaten by grazing animals and carried onward. To realize that nature's speed champion is not a predator but a humble fungus is to reconsider where power truly resides. Wonder, it seems, often hides in places we overlook. Some mushrooms appear as if they belong to another world entirely. Coral fungi rise from forest floors in branching forms that mirror underwater reefs, pale whites, fiery oranges, and soft creams spreading outward like frozen waves. They twist and fork into intricate structures that resemble marine life transposed onto land. These shapes are not coincidence, but efficiency. Branching maximizes surface area, increasing spore release. Yet the result feels sculptural, almost intentional. Antlers, flames, coral, bone. Life repeating its favored geometries across environments. The same architectural language spoken by reefs beneath the sea and fungi beneath trees, echoing patterns older than forests themselves. Other mushrooms take on gentler forms. After rain, delicate clusters rise in meadows and woodland clearings, their caps spreading like tiny umbrellas or parasols. Some are so thin they glow when sunlight passes through them, translucent as tissue paper. These mushrooms live briefly, sometimes lasting only a day or two before collapsing back into soil. Their beauty is fleeting, but unforgettable. Caps shelter spore-bearing gills beneath, while slender stalks lift them into passing air currents. Evolution shaped them into one of nature's most iconic designs, instantly recognizable across cultures and ages. Children draw them instinctively. Fairy tales crown them with red caps and white spots. Biologists study their elegance. Ephemeral yet enduring in memory, they rise again with every rain. Fungi may also hold solutions to one of humanity's greatest challenges: carbon capture. Mycorrhizal fungi form deep partnerships with trees, channeling carbon-rich sugars underground and locking them into soil for centuries. Some species produce compounds resistant to decay, effectively sequestering carbon in stable forms. Scientists are exploring how fungal networks could be encouraged to expand this natural process, transforming forests and soils into powerful carbon sinks. Imagine addressing climate change not only with machines and technology, but with living systems, threads beneath our feet quietly drawing carbon back into the earth. In the patient labor of fungi may lie one of our strongest allies. Looking even farther ahead, fungi may accompany humanity beyond Earth. If humans settle Mars or other planets, fungi are likely to be among the first organisms we bring along. Their resilience allows them to break down rock into soil, recycle waste, produce food, and tolerate radiation and low gravity. Mycelium can be grown into strong, lightweight, biodegradable structures, suggesting future habitats that are cultivated rather than constructed. Scientists envision fungal biodomes, living architecture expanding and repairing itself over time. In these visions, fungi are not background organisms but foundational partners, helping transform hostile worlds into habitable ones. From ancient rituals to future planets, from invisible spores to living buildings, mushrooms continue to stretch the boundaries of what life can do. Quiet, adaptable, endlessly inventive, they remind us that the most powerful forces are often the least conspicuous, patiently shaping worlds from beneath the surface. This vision reaches far into the past, echoing the earliest chapters of life on Earth. Hundreds of millions of years ago, before forests rose and before plants fully claimed the land, fungi were already there. They were pioneers in a raw and hostile world, creeping across bare rock, breaking stone into soil, preparing the ground for everything that would follow. Long before trees cast shadows, fungi laid the foundation beneath them, and it is this same ancient skill, refined through unimaginable stretches of time, that may one day travel with us beyond Earth. If humanity ever settles distant worlds, it may not arrive alone. Fungi could once again be the quiet architects, weaving life into lifeless ground, turning alien landscapes into places where ecosystems might take root. They have done it before. They remember how, without fungi, life on Earth as we know it would unravel. Remove them from the planet, and the living systems around us would collapse with startling speed. Forests would suffocate beneath layers of undecomposed leaves and fallen wood. Nutrients would no longer cycle back into the soil, washing away or locking themselves beyond reach. Plants, stripped of their fungal partners, would struggle to gather the minerals they need to survive. And without plants, animals, including humans, would have nothing to eat. Even the air we breathe depends on the balance fungi help maintain, sustaining the ecosystems that generate and recycle oxygen. Fungi are not background organisms. They are recyclers, collaborators, healers, and engineers. They work invisibly, yet their absence would be catastrophic. Every meal we eat, every forest we admire, every breath we take exists because fungi quietly keep the system in balance. They are not supporting characters in the story of life. They are the stage upon which the story unfolds. And so we come gently to the end of this quiet journey through the fungal kingdom. We have drifted from glowing lanterns in moonlit forests to spores floating unseen above busy cities, from underground networks older than trees themselves to possibilities that reach toward distant planets. We have wandered through a world that is hidden yet essential, delicate yet nearly indestructible. Mushrooms remind us that life does not need to be loud to be powerful. Much of the planet's most important work happens in silence, beneath our feet, carried out by threads so fine they can slip through stone itself. Fungi teach us patience. They teach transformation. They take death and return it to life. They store water for dry days, feed creatures great and small, stabilize soil, and whisper chemical messages to plants through vast underground webs. Without them, there would be no bread rising in warm kitchens, no forests climbing toward the sky, no rhythm to Earth's endless cycles of renewal. As these thoughts begin to settle, imagine the slow, steady pulse of mycelium beneath you, a heartbeat of the soil, calm and unhurried. Imagine spores drifting like stardust, carrying possibility into every corner of the air. Imagine soft green glows in the darkness of the forest, quiet beacons reminding us that even in shadow, life continues to shine. This is the comfort of science told slowly, the realization that the world is stranger, richer, and more deeply connected than we can ever fully perceive. And that by simply pausing, by choosing to notice, we can glimpse the extraordinary woven into the ordinary. If this journey has brought you a sense of calm or wonder, you're welcome to share the curiosity by liking, subscribing, or leaving a thought behind. It helps this small community of dreamers and science lovers continue to grow. But for now, there is nothing else you need to do. You can allow the story of mushrooms to fade gently, like the last light slipping from the sky at dusk. If sleep arrives, let it carry you softly. If you remain awake, you are welcome to linger, to listen again, or to drift onward into another quiet exploration of the universe. Rest well, and remember, the world is filled with hidden marvels. Sometimes they rise overnight, like mushrooms after rain, and sometimes they have been waiting patiently for you all along, just beneath the surface.